Hello everyone, welcome back. So today we'll start with a new data structure, which is the queues data structure. So far we took the stack data structure, which is last in, first out. So last in was first out, or what we call LIFO data structure, and we saw how to implement it in C. And I suppose you have seen in the lab how to do some exercises on it. I will follow up on that. Now we'll start with a queues data structure. So what is a queue? You have all been in a queue before. So in a queue, there's an order in which you arrive. Usually the first guy who arrives is the first guy who leaves a queue. Whenever anybody gets in the queue, he has to wait until all the people in front of him finish in order to execute his job. So accuse is, we say it first in, the first guy in is the first out. However, in a stack, the last in is the first out, right? Okay, so Q is first in, first out. Whoever comes has to wait for all the others to finish in order to proceed. This is a data structure that we will talk about. We'll see different functions for it and we'll implement them in C, and in the lab you will do the implementation. So we'll do the implementation at home. You will write down the implementation that I give you and run it, make sure it's running, and do some exercises on them. So Q is a linear data structure. This data structure can be described with an analogy of waiting in a line, as we said. So therefore, it has a back end and a front end. Okay, there's a back and a front. The standard operation on a queue are push, you push an element in a queue, pop, you remove an element from the queue. Front, it actually reads or returns the value of the element at the front of the queue. Back returns, okay, the element at the back of the queue. So let's consider an empty queue. With an empty queue, the front and the back are both null because it's empty. If we say that front is a pointer to the front element, then it's equal to null. If the back is a pointer to the back element and it's equal to null, then the queue is empty. Okay, so when the queue is empty, the first point says the front and back of the queue has a value of null. If we apply the pop operation on an empty queue, there's a problem. We will have an underflow error. So before we pop from a queue, it goes without saying that we should actually check if the queue is empty. Let's look at this example. Push the following integer elements to the queue. You have 44, 33, 24, 78. We'll start with push 45. So push 33 would be pushed, okay, after 45, right? From the back. Yes. So this is 33. Push 24 from the back. Now back is pointing to 24. Push 78. Now back is pointing to 78. Pop. If I pop, you don't usually pop. You don't put any pointer. You return pointer to the popped element. So pop always pops from the, as we agreed, from the front. Okay, so now front is pointing to what was the first element, 45. So pop pops 45, and now front is pointing to 33. Pop again, 33 is removed, and front is now pointing to 24. Okay, push 59. Again, you push it from the back. We're showing that each pop is from the front and each push is from the back. So this was an overview of how Q is. Now let's see how to implement it using the C language. So we'll do an implementation of a numeric queue the same way we did with stacks. We're going to look at pushing an element in a queue, popping from a queue, checking if the queue is empty, and printing all elements in a queue. So as we did with the stack data structure, we'll start by defining the new data item. Analogous to what we did in stack, we created a structure item. So item is a structure. It's composed of two parts or two data items, which are the number and pointer to next item. So throughout the course, we'll actually have we're going to have such items where it's composed of the item, which is in this case a numeric item, a number, and a pointer to the next item. So P next item. And to start with, my Q, like my stack, is the pointer to the first item. One of the exercises that I give to students at the end of Qs is to actually implement Qs using two pointers, pointer to back and pointer to front. In this example, we are going to have only pointer to first item. So can we manage all the Q functions using only pointer to first item? So let's see. Yes, we can, and we'll see how to do it. So item star P first item. So P first item is a pointer to an item, and it's equal to null. So this is going to be my Q. And to begin with, the Q is empty. We will start with the create a new item function. So create a new item, okay? I'm going to give it the number from which I'm going to create an item object, an item structure, and it's going to return a pointer to this item. So the first line here is using the malloc function. I actually create the new item and I reserve for it the size of item. So new item now is a pointer to an item, okay, with the memory location or memory space of size of item reserved for it using the malloc function that we talked about. So new item is a pointer to an item. At the end of this function, I'm going to return this new item. But before I return it, I will set the number part. We said that every item has two parts. It has a number part and it has a P next item, which is a pointer part. The number part is equal to new number because I'm creating a new number, having this new number, let's say 25. So new item, instead of dot, we use an arrow because it's a pointer. So new item dot number is equal to new number, which we pass to the function create new item. And the pointer is equal to null because when we create an item, okay, we don't set the pointer. We set the pointer whenever we push it to the queue. So first of all, when you create an item, you have a number, you want to create the item, you set the pointer equal to null, and of course return new item, which is a pointer to an item which contains this number. Okay, so the item contains this number here. This is create new item. So this is analogous also to what we did in the stack data structure. Freeing item function, every malloc, okay, that you use in your program should be at the end of the program followed by a free. So free, whenever you delete the item, you have to free the memory that you have reserved using malloc. So free P item. So we pass to it the pointer to the item that we want to delete, and we just put the word free P item.